Good day. Today we'll be looking at indices. First of all, what does the word and the topic mean? Well, the singular word index and its plural is indices. Basically, indices or an index refers to a power or an exponent. Now, in mathematics, an index is a small number written above and to the right of a base number, indicating how many times the base is multiplied by itself. Now, an example of this is a raised to the power of n, where in this case a will be our base and n will be the index or power or exponent. Now, this in numerical terms can be expressed, for example, 2 raised to the power of 4. 2 here will be taken as the base number and 4 as the index or exponent. Now, what is the base? The base is the main number of variable being multiplied, while the index, power, or exponent is a small number showing the number of repetitions. Now, this can be expressed as 2 times 2 times 2 times 2. We know this is repetitive 4 times because of the index or exponent. So we can multiply the base 4 times, and this can be simplified in this expression. So this is the beauty of using index or indices. It fosters simplicity. Now let's look at some common laws of indices. Please keep alongside you your pen and your biro or any jotting material so you can engage yourself throughout the tutorial. Now, common laws or laws of indices. First, we have the law of multiplication. This is expressed as if you have a raised to the power of m times a raised to the power of n. This can be written as a raised to the power of m plus n. Secondly, law of division. If you have a, which is the base, and m, the index, divided by a, also the base, and n, the index, this is equivalent to a raised to the power of m minus n. Now, please note for law 1 and law 2, the bases are same. That is the condition, the bases have to be same. Thirdly, power of a power. So for instance, if you have a raised to the power of m multiplied by n and index n, this is equivalent to a raised to the power of m times n. Fourthly, zero power law. A raised to the power of 0 is 1. So any base raised to the power of 0 is equivalent to 1. This is what it's simply saying. 2 raised to the power of 0, 1. 4 raised to the power of 0, 1. Remember, the base is a variable, so also the index. Hence, we use these letters to express the concept. Next, we have negative index law. a raised to the power of negative m is simply the reciprocal of a raised to the power of m. And next we have fraction index. So a raised to the power of m over n is equivalent to square root of, is equivalent to the nth root of a raised to the power of m. Then number 7, this is a simplified form of law number 6. A raised to the power of 1 over n is simply the nth root of a. Now let's take some examples so we can fully understand and digest these laws. So example 1, a. Simplify 10 raised to the power of 5 times multiplied by 10 raised to the power of 2. Now, from the laws we have, law number 1 will work best. Same base, so we can use the law of multiplication of index. So this is going to be 10 raised to the power of 5 plus 2. This is going to be 10 raised to the power of 7. And this is faster than the traditional method. The traditional method would have been we expanding this 10 times 10 multiplied by 10 multiplied by 10 multiplied by 10 5 times, then multiplied by 10 multiplied by 10, and this will also be equivalent to 10 raised to the power of 7. So this law makes simplification faster. B. For B, we have 22 n raised to the power of 7 divided by 2n raised to the power of 3. Now I'll focus, this and this are our bases. This is the coefficient of n raised to the power of 7, so also is this the coefficient of n cubed. Our focus is n raised to the power of 7 and n raised to the power of 3, and this are like bases, so we can use the law of division. That's law number 2. So this is going to be 22 n raised to the power of 7 divided by 2n raised to the power of 3. This will cancel out, and this will be equivalent to 11 n raised to the power of 7 minus 3, and this is going to be 11 n raised to the power of 4. Now we move to C. 19 raised to the power of 0. We know from our law, zero power law, this is going to equal to 1. But this, for understanding, can be expressed as 19 raised to the power of a over 19 raised to the power of a. From our division law of indices, we know this is going to be 19 a minus a. This is equivalent to 19 raised to the power of 0. But back to here, this and this are same. So this divided by this is equivalent to 1. So this is an aided understanding to give you a picture of why a number base raised to the power of an index which is 0 will be 1. Now we move on to D, and the question is 5 raised to the power of negative 2. Now this, we use negative index law to easily simplify this, and this will be equivalent to 1 over 5 raised to the power of 2, which is equals to 1 over 25. Now, similarly as we did in C, I'm going to show you a picture of what is going on here. So 5 raised to the power of negative 2 is equivalent to 5 raised to the power of 0 minus 2. Now this will be same as 5 raised to the power of 0 all over 5 raised to the power of 2. And remember, 5 raised to the power of 0, anything raised to the power of 0, base raised to the power of 0 is 1, divided by 5 squared, 25. Now we move to E, and our question for E is 2 raised to the power of 3 times 1 over 6 inverse. Now 2 raised to the power of 3 is 8 times, now this 1 over 6 inverse, let's assume 1 over 6 to be A, so this is simply like saying A inverse, and what do we know A inverse to be? 1 over A. So simply this is just saying 1 over 1 over 6. Now 8 multiplied by, this is going to simplify to 6. When you take the inverse of 1 over 6, you have 6. So this is going to be 48. Next we move to F. Now for F, you will notice a use of more than one of the laws. So for F, the question is R, which is the base, times R raised to the power of 0 times R raised to the power of negative 5. Simplifying this using the multiplication law, this is going to be R raised to the power of 1. This R here has a power of 1 plus 0 plus negative 5. Now this simplifies to R raised to the power of 1 minus 5, and this gives R raised to the power of 1 minus 5 is negative 4. Now from our negative index law, we know this is the same as 1 over R raised to the power of 4. So this is our answer. Now let's dive a bit deeper. G. Now we're going to look at the product, that is power of a power rule. So x squared all cubed. Now this is a product of indices. This is one index and here's another. So this is a product of indices. Now from rule number 3, we have this is going to be x raised to the power of 2 times 3, which is going to be x raised to the power of 6. This is our answer. Now to help you understand why this and how much easier it makes it, traditionally this will have been x squared times x squared times x squared, apologies, and this is still going to simplify to x raised to the power of 6, because this is going to be x raised to the power of 2 plus 2 plus 2. Now this is the beauty of products of indices. Moving on to the next question, we have 8 raised to the power of negative 2 over 3. Now 8 can be written as 2 raised to the power of 3, and this is raised to the power of negative 2 over 3 from the original question. Now here we have another product of indices, so this is going to be 2 raised to the power of 3 times negative 2 over 3. This is going to simplify to 2 raised to the power of negative 2, and over here we have negative index, so this is going to be 1 over 2 square, and this is going to be equal to 1 over 4. Now moving on to the next question, we have 16 over 81 raised to the power of negative 3 over 4. Now we have a negative index, and anytime we have a negative index, we take the inverse of the base. So the entire of this, the whole of this is our base, and we have a negative index, so the inverse of our base is going to be 81 over 16, and this is going to be raised to power of 3 over 4. Just in case you do not get what's happened here, the inverse of the inverse of 16 over 81 is going to be this, and since we've applied the rule of negative index, this is going to be 3 over 4, but now this is same as 1 over 16 raised to the power of 3 over 4 divided by 81 raised to the power of 3 over 4. Now because they have the same index, that's why this expression will simplify to this. So this 3 over 4 here is distributing both to 16 as an index and 81 as an index of 8. And this is how we came about 81 over 16 raised to the power of 3 over 4. Now this is very similar to our fractional index, and this can be expressed as 81 over 16 all cubed, and this is going to be to the 4th root. Now we can also express this as the 4th root of 81 over 16 to the power of 3. This and this are homogeneous. Homogeneous in the sense that they are same. Now The fourth root of 81 is 3 plus or minus 3. 3 raised to the power of 4 is going to be 81. So also the fourth root of 16 is plus or minus 2. Now you may be wondering, why do we have a positive or negative 3? That's because if you take 3 raised to the power of 4, you have 81. So also if you take negative 3 and take it to the index of 4, you will also have 81. Now this is going to be, we're going to take 3 to the index of 3, that is 3 cubed. 3 cubed is going to be 27, divided by 2 cubed is going to be 8, because of we have an index of 3 here. I hope you found this helpful. I'm going to post a link in the description to an extended video where you'll have a variety of exercises which you can join along and solve. Please subscribe to stay notified and click on the bell icon to get updates on any latest videos or posts. Have a nice day.